Chapter 2.3 Gauss or Divergence Theorem. So recall that if a vector field F represents the flow of a fluid, then the divergence of F, you can write like this, divf represent the expansion or the source or compression sink of the fluid. So the triple integral of divergence F over a region is equal to the surface integral of F over the surface of the region, which has outward pointing normal. So the divergence theorem, also known as Gauss's theorem, states that the surface integral is equal to the triple integral over the solid region of the divergence of F dv. Here dv is our differential volume, which in Cartesian x, y, z coordinates, which simply be dx, dy and dz. So similar to the Green's and Stokes theorem, first you have to sketch the region, and then if the question asks you to verify or prove, you need to calculate both sides and show that the left hand side is equal to the right hand side. And if the question asks you to evaluate, you have to calculate one side only. If the question asks you to evaluate surface integral f dot n ds, then you have to show the calculation of the triple integral divergence f dv. Example 1. Verify the divergence theorem for f xyj plus zk, where s is the surface given by the paraboloid, z is equal to 4 minus x squared minus y squared, with z is greater or equal to 0. First step is to sketch the figure from the given equation z. You can sketch the figure. Okay, this is the x-axis, y-axis and z-axis. So this is the base of your paraboloid, and this is the curve at the top at z equal to 4. The base with the radius 2. We name this curve surface as S1 and the base surface here as S2. And now let's show that the left hand side is equal to the right hand side. And let's do the calculation for the left hand side first, the triple integral. Okay, first you need to find the divergence f. So given f here is xyj plus zk. So you have to differentiate each of the element here. Okay, first element differentiate with respect to x. Second element differentiate with respect to y, and the third element differentiate with respect to z. Okay, so first element equal to 0, second element del y xy, so you get x, and del z you get 1. So divergence f or del dot f is equal to x plus 1. You have to use the cylindrical coordinates for paraboloid. So x is equal to r cos theta, and dv is equal to r dr d theta dz. Z is from 0 to 4 minus r. Why 4 minus r? Because from this equation, z is equal to 4 minus x squared minus y squared. So you know that the circle equation is equal to x squared plus y squared equal to r squared. So from this, z is equal to 4 minus x squared plus y squared. So z is equal to 4 minus r squared. So this curve is given by this equation. z is equal to 4 minus x squared minus y squared. So that's how you get 4 minus r. And then your r is from 0 to 2. Okay, this 0 to 2. And then your theta is from 0 to 2 pi. Okay, the full circle of the base is from 0 to 2 pi. You have to integrate the limit that has the variable first. Okay, so you just rearrange the value here. So I want to integrate with respect to z first, because the limit of z, you have this variable r here. Okay, dz dr d theta, r cos theta, this is equal to x plus 1. This is the value of our divergent f, and this is our dv. Multiply r, this r, set the bracket, so you get this value. Then integrate this with respect to z. We get z r squared cos theta plus zr. Substitute the lower and upper limit. Okay, simplify this, and then integrate this with respect to r. Again, substitute the lower and upper limit and simplify. Okay, and the last part, integrate with respect to theta. You get this, substitute this upper limit minus the lower limit, simplify, then you will get 8 pi. Okay, this is for the left hand side. Then you have to do the right hand side, the surface integral. So this is the figure here. We will start with this surface first, S1. You can find your n by referring at the table from your textbook, and then using the cylindrical coordinates. Okay, x equal to r cos theta, y equal to r sin theta, and ds is equal to r dr d theta. Then your r is from 0 to 2, and your theta is from 0 to 2 pi. You want to find your f dot n ds. This is your given f. This is your n. Calculate the dot product. You get this. And then substitute your z. You have this z here. Substitute the value of z. So this is your f dot n, and this is your ds. And write down your limit 0 to 2, 0 to 2 pi. And then simplify this equation. Integrate with respect to r. Simplify. And then integrate with respect to theta. You have to do the integration by substitution here. Substitute the upper and lower limit. Then you will get 8 pi. This is for S1. The S2 is this base here, this surface. Okay. So z equal to 0, n is equal to negative k. Do the surface integral f dot n ds. This is your f. This is your n. So you get 0, 0 minus z. Then z is equal to 0. Then your integration will be 0. Then the last part, you need to find the total of f dot n ds for S1 and S2. So 8 pi plus 0, you get 8 pi. Then you just show that the left hand side is equal to the value of the right hand side, which is 8 pi. Okay, so this is the table for n, or the normal vector. You can refer this from your textbook. Example 2. Given vector field f is equal to 2xi plus 3j plus z squared k, where surface S is a cube for x from 0 to 1, y from 0 to 1, and z from 0 to 1. Use Gauss' theorem to evaluate triple integral of divergent f dv with outward orientation. So in this case, the question asks you to evaluate this triple integral. So you have to calculate the double integral. Okay, so I will show both sides, but in your exam you just show one side, okay, because the question asks you to evaluate. Okay, I just want to check whether the left hand side is equal to right hand side, so that's why I calculate both sides. Okay, first we'll sketch the figure. Okay, so this is your cube with all these limits. So you can see that you have 6 surfaces here: S1, S2, S3, S4, S5, S6. First, let's solve from left hand side. You find the divergent f. Okay, del x to x, you will get 2. Del y, 3y, you will get 3. Del z, z squared, you will get 2z. Okay, 2 plus 3 equal to 5 plus 2z. Next, use Cartesian coordinates. Okay, so dv is equal to dx dy dz. Okay, with this limit x from 0 to 1, y from 0 to 1, and z from 0 to 1. Okay, so this is your divergent f, this is your dv, and this is all the limits. Okay, substitute and then integrate with respect to x. You get this value. Substitute the lower and upper limit. You get this. Integrate again with respect to y. You get this value. Substitute the limit and then integrate with respect to z. Simplify. Then you get the left hand side is equal to 6. If you want to solve from right hand side, it is a bit complicated because it involves 6 surfaces. So double integral f dot ds, integrating each part of the surface. So start with x1. So for the surface integral, you just do for each of the surface. Then you have to sum up all the value of the surface integral for S1 until S6. Okay, so 2 plus 0 plus 1 plus 0 plus 3 plus 0, you get 6. Example 3. Use the divergence theorem to evaluate surface integral f dot ds of the vector field f. Okay, 2xy, 8xz, 4yz. Okay, where S is the surface of tetrahedron bounded by the plane x equal to 0, y equal to 0, and z equal to 0. And z is equal to 1 minus x minus y. First, you have to sketch the diagram. So this is your tetrahedron. So how did you get the value of 1 here? Okay, so for the x-axis, okay, let's say this is the base of the tetrahedron. Okay, this is the base. Okay, for this value y, just plug in 0 in x and y. Okay, into this z equation. So you get y equal to 1. And then for x, similarly, just plug in 0 in y and z. So you get x equal to 1. And for z, plug in 0 in x and y. So you get 1. Okay, now let's calculate the volume integral of divergent f dv. Okay, first let's find the divergent f. Okay, del x, 2xy, you get 2y. Del y, 8xz, you get 0. And del z, 4yz is equal to 4y. Simplify this, you get divergent f is equal to 6y. Okay, so now let's identify the limits for x y, and z. This is the base of the tetrahedron. If you looking from above the tetrahedron, you can see that x is from 0 to 1. So limit for x is from 0 to 1. But for y, it also from 0 to 1. But value of y depends on the value of x. For example, at x here, you get y here. Okay, at x value here, so your y will be here. So y value is going to be dictated by some function for y in terms of x. So what you have to do is to take z is equal to 1 minus x minus y, plug in 0 for z, and solve for y. So when you plug in 0 here and solve for y, you get y equal to 1 minus x. Okay, so your y will be from 0 to this line equation, 1 minus x. Okay, so this is your limit for y. And for z, when you look at the z-axis, the lowest value here will be 0. But we don't know how high the z value can go, and the height of this solid is going to be dependent on our original equation here. This is our original equation. So to find the height of z, you have to take z equal to 1 minus x minus y and solve for z. Okay, so you will get z is equal to 1 minus x minus y. Okay, so this is the limit for z. Now you need to figure out your order of integration. Okay, which one you have to integrate first. In order to figure out your order of integration, you have to look at the variable that involved in the limit of the integration. So you can see here z, you have two variables, x and y. Okay, two variable. And then y, you have one variable, x. And for x, you have 0 variable. Okay, only two constants, 0 and 1. You need to integrate with respect to the variable that has the most variable involved in its limit. Okay, so you have to integrate this first, z, with two variable, and then integrate with respect to y with one variable, and then integrate with respect to x. Integrate with respect to z, y, and x. Okay, write down your limits correctly. And 6y is your divergent f. And this is your dv. Okay. So just integrate respect to z. Simplify. Substitute lower and upper limit. Integrate with respect to y. Substitute lower and upper limit. Simplify. And then integrate here with respect to x. Simplify. Then you will get 1 over 4. Okay, so this is the value of your triple integral divergent f dv, 1 over 4. Okay, that's all for today. Thank you.